In this video, I'm going to talk to you about rational expressions. Rational expressions are basically fractions that include variables. So before I show you one of those, I want to first just review with you I'm just going to call it the basics of reducing a fraction. Okay, so we have 64 over 108, and the method, the process that you probably go through when you factor this, or when you reduce this, is to factor. Like you think of, okay, 64 is what times what are some ways you can break down 108, and then you simplify out the common factors to get to the answer. So hopefully you're okay with something like this. But what I want to point out, because I see this a lot in my classes, is that you can't break apart the number. So for example, the 4 and the 8, just because they're both in the ones position and they're both divisible by 4, you can't just simplify the 4 and the 8, because they belong to a bigger number. It's not just a 4 by itself and an 8 by itself. And that will make more sense when I show you this next example, because that's a really common pitfall, is to try to cancel part of the number without canceling the whole number. So basically what you probably do in your mind, so I'm going to just draw a cloud here, because you probably do this so quickly that you're not even realizing you're doing it. Probably break down 64 to 8 times 8. And then you can break 108, we can do 9 times 12. Just break it into smaller numbers, and then you can go through and factor from there. So let's see, the 8 and the 12, they both share a common factor of 4. So if you divide this out, this is a 2 and this is a 3. Now the reason we can only look at the 8 and the 12 is because it's no longer connected to the 8 and the 9. It's connected by multiplication, and so we can use division or factoring to factor out a common term. So that's why we can do this. But you probably do this in your brain, and then from here we're going to multiply 18 times 2, which is 16, and then 9 times 3, which is 27. And that's the most simplified answer for this fraction. But let me show you some with variables next. Okay, so take a look at this example. This is what really is called a rational expression. This is a fraction. Here we have some variables in place. And what I was talking about a few minutes ago about you can't break up a number, this is a perfect example. For the 3 and the 9, they both are divisible by 3, okay? But because of this addition sign, they're glued to the rest of this expression. Like they are one complete number, even though it looks like it's separate numbers. The same thing goes with this a and the numerator. Even though they are single a's, it looks like you could just cross them out. You can't, because they belong to a bigger number. And so the only thing you can do when you start these problems is to factor the expressions that you have. When you factor, I really do want you to rewrite the problem. For this example, a plus 3 is already in its most factored form. But we can do something with the denominator. So two numbers that multiply to 9 and add to 6, that's going to be a 3 and a 3. Okay, now you can cancel, as long as you have this exact same expression, the a plus the 3, you can cancel it or simplify, reduce, whatever words you want to use here, with another a plus 3, as long as it's exactly the same, which we have 2 to choose from. It doesn't matter which one you cross out. Okay. Now, guys, when your entire numerator crosses out, you still need a number to stand on top. I tell my students in my class, you have to have a number to stand on top so that your denominator doesn't get loose. So just put a number 1 right there to stand when your entire numerator is crossed off. So the answer to this problem in most simplest form is 1 over a plus 3. Okay guys, take a look at this last example. This one is arranged differently than our previous problem because there are no plus and minus signs. So these are just one-term expressions in the numerator and in the denominator. So we're going to approach this one slightly different because the connection between these coefficients and these variables are multiplication. And so we can go ahead and divide out the common terms without doing any kind of factoring. The best way to approach a problem like this is to go slow and to do simplify one step at a time. I want you to first, we're going to simplify the coefficients, then we'll simplify the a variables and then the b variables. All right? Okay, so if we were to simplify the 16 over 24, okay, 8 goes into both of them. That's the greatest common factor. So if you divide an 8 out of 16, you're left with 2. Divide an 8 out of 24, you're left with 3. Okay, so far we have a 2 in the numerator and a 3 in the denominator. Okay, focus in on just the a terms. You have 4 a's in the numerator and only 1 a in the denominator. We're going to follow the rules or the steps of the quotient rule. We can subtract these two exponents. Since there's 4 minus 1, this is really a 1 right there. That leaves 3 a's in the numerator. And then there's 2 b's in the numerator, 3 b's in the denominator. So there's 1 extra b in the denominator, so that's the one that stays. And then check this work real quick. See if there's anything else that would be a common factor before you declare that this is your answer. But in this problem, it doesn't. 2a cubed over 3b is the final answer. There's some problems I want you to try practicing simplifying rational expressions, so pause this video and get out your work.